2022 Indian Mathematical Olympiad IOQM 2022 problem number 2. The problem says find all natural n for which there exists a permutation sigma of 1 to n such that there exists, as it says, permutation sigma, that sigma I, this one, times negative 2 to the power of I minus 1 equals 0. So when you want to solve this problem, as I said before, one of the most important useful idea, considering a small example. For example, you could suppose that n equals 1. So here, the permutation is arrangement of 1 to n. So if n equals 1, we want to see, do we have, for example, sigma I, a permutation that is good? So it will be 1 times negative 2 to the power of 1 minus 1, and it will be what? Negative 2 to the power of 0. 1 is not 0, so for n1 it's not good. For n2, if we consider 2, 1, so let me write this. It is what? Sigma 1, negative 2 to the power of 0 is 1, and then if you replace with 2, it will be sigma 2, negative 2 to the power of 2 minus 1. It will be negative 2 sigma 2. And if you replace I with 3, it will be 4 plus 4 sigma 3 minus 8 sigma 4 and 2 negative 2 to the power of n minus 1 sigma n. So here, if I want to calculate for n2, if I consider it is 1, 2, it is not 0. If I consider 2, 1, so for this permutation, you say 2 minus 2 times sigma 2. So sigma 1 is this, 2 times 1 is 0. So we see that there exists here a permutation. So if you consider sigma 1, sigma 2, sigma 3 to sigma n, you multiply this one by 1, the next one by negative 2, the next one by plus 4, the next one negative 8, and this one negative 2 to the power of n minus 1. And you want to find arrangement 1 to n that it equals 0. For n3, if I want to find 0, so as you can see, all of them are even because multiplied by 2, 4, so sigma 1 should be even. So if you consider 2, and you should consider 2, 1, 3 and 2, 3, 1. 2 minus 2 times 1 plus 4, okay, it's not good, but what about this case? 2 minus 2 times this, it will be minus 6, plus 4 times this, plus 4. 2 plus 4 minus 6 is 0. So also for n3 is good, n2 is good, n1 is bad. So maybe we guess only n1 is bad, or by n4 we understand. If n4 also is bad, we conclude that we guess 3k because the repetition will be 3. 3k plus 1 are bad. Okay, so let's consider for n4, you should consider sigma 1 is even, so it should be 2 or 4. And if we consider, we know also it is multiple of, it is 0, it should be 0. So it is multiple of 4. So because these things are multiple of 4, here you should place something that these two things be multiple of 4. 2, so this one should be, again, negative 2. If you place here 1 times this 2, negative 2, 1 is okay. Let's consider 2 with, for example, if you place 2 here is not okay. 2, if you place 3, 2 minus, okay, it's okay. 2, 4, it's not okay. If you place 4 here, it can be 2 and what? 4. We can't have 4, 4. If you replace 4, for example, negative 2, 4, negative 2 times 3, all of them are bad. So we consider 4, 2 only. So for each of them, you check, okay, 2, 1, 3, 4, 2, 1, 4, 3 to check them. 2, 3, instead of 4 factorial 24 cases, we only need to check 6 cases. 2, 3, 1, 4, and let me move it a little down. 2, 3, 4, 1. And this one, 4, 2, 1, 3. And the next one will be 4, 2, 3, 1. Now I know what? I know the first one I should multiply by 1 the next one -2, the next one +4, and the last one -8. So if I check for each of them, let's see that we reach what? If I write the rest of that with black, this one. It will be 2 minus 2, 4 times 3, 12 minus 32. And we will say it is negative, it's not 0. The next one. 2 times 1, 2, 1, -2, 4 times 4, 16, 3 times -8, -24. It's -8. If we calculate, it will be -8. Also, if we want to calculate, we can say exactly each of them is what. 2 minus 2 will be cancelled. 12 minus 32 is -20. And they are not 0. This one, 2, 3 times this -6. 1 times 4, 4. 4 times 8, -32. Again, this one, 2 plus 4, 6. It will be -32. And the next one, 2, -2 times this -6. 4 times this 16. 1 times this -8. 16 minus 8, 8 minus 6, 2. 2 plus 2, 4. It is not 0. And if you consider these two cases and they are not 0, we understand N4 is bad. And we guess that we should consider mod 3. So 4 times 1, 4. -4. 1 times 4, 4. -24. They will be cancelled. -20. It's not 0. And the last one, 4 times 1, 4. 2, -4. 3 times 4 plus 12 minus 8. They will be cancelled 4. So it is not 0. So N4 is bad. Now we guess what? We guess N1, 2, 3. If we consider the period, our claim is if N is 3k plus 1, like 1, 4, it is bad. Otherwise, it's good. So at first, let's consider 1a. N equals 3k plus 1 is bad. Let me copy the main equality here. So see now, because we are working with period 3, we consider mod 3, and we can see what? Here, the first one is what? Sigma 1 times, suppose n equals 3k plus 1, and we want to see the left side will be what? We want to prove this part by contradiction. Okay, so let me consider n 3k plus 1, and this sigma will be sigma 1 times 0 minus, if you replace I with 2, it will be 1 -2 sigma 2 plus 4 sigma 3, and so on. So if you consider mod 3, it will be what? The first one, sigma 1. -2 is what? -2 mod 3 is 1, so plus sigma 2. And plus 4, it is 1 again, sigma 3. So we can say what? We can say, if we consider -2 to the power of I minus 1, if we consider it mod 3, it will be what? -2 mod 3 is what? Is 1. So it will be 1 to the power of I minus 1, and it's 1 mod 3. So we understand it will be sigma 1 to sigma 2 to sigma n. And it should be what? It should be 1 to n. 1 to, with another, for example, arrangement, because it is permutation of 1 to n. So it will be 1 to n, and we know we want to prove by contradiction. We suppose that, let me write last one, n minus 1 sigma n, and it should be 0 mod 3. So here I can say it is what? N times n plus 1 over 2 mod 3 is 0. So we can conclude what? 3 divides their difference. So 3 divides n times n plus 1 over 2. So 3 divides n, or 3 divides n plus 1, because it is over 2, 3 and 2 are relatively prime. So we can conclude that. So n mod 3 is 0 or -1 or 2. So we've proved that here for n mod 3 contradiction when n is congruent to 1 mod 3. Now for 0, 2 we should create. So let's see, for 2 and 1, for 2 and 3, we've created what? 2, 1 and 2, 1, 3. Now we want to see, can we use smaller one, 2, 1, and for 3, 2, 1, 3. It was this. Now we want to see for 4, can we create, if we use, for example, from, for 4 we said it is impossible. For 5 and 6, for example, this one, if I can use, for example, like induction, n to n plus 3, then I can say, okay, by 2 and 3, I can prove for all 3k plus 2 and 3k. So if I want to create this one, okay, so like 4, for example, the first one you can say 4, and 4 I've considered some cases to see like this one. Okay, I said, for example, the first one should be 2, the next one the first one should be even, so for 2, the next one 1 and 3 are possible for. If you consider some cases here, you will find a good example for 5. And the good example, if you find, it will be 2, 3, 5, 4, 1. Let me check that. If I write rest with black, you should multiply this by 1, multiply this by -2, the next one by 4, the next one by -8, and the next one by 16. 2 times 1, 2, -6, 5 times 4, 20, -32 plus 16. So it will be what? It will be -16. Here it will be 4, 4 plus 2, 6 minus 6, 0. Now, you will see, for example, if you want to try a pattern, you can say, okay, 2, 1, n plus 3, you see this part, this plus 3, this plus 3, 5, 4, and then 2, 3, 1 here. So, for example, if you want to write with the same pattern here, you say, okay, 2, 3, and this plus 3, 5, 4, and 6, and the last one is 1. So, if we multiply by, let me write with blue, this one by 1, this one by -2, this one by 4, this one by -8, 16, and 32. So let's consider this, and then we prove for general variable n. So 2 times 1, 2, -6, 20, -32, and plus 96. This one, sorry, it's -32. -32. So here you say, okay, this minus this is 64, this minus this is 32. And okay, so here it's not 0. Let's check 3 here. 3, we said 2, 1, 3. Oh, 2, 3, 1. Okay, so let's correct this part. It is 2, 3, 1. And if we correct this part, it's 2, 3, 1 here. And then if you add by 3, it will be 5, 6, and 4. So let's check this one again, the calculation. 2 times 1, 2, -6 plus 5 times 4, 20, minus 48, plus 64, minus 32. So if we calculate this part, it will be 32, it will be -16, it will be 4, and it will be 0. 4 plus 2, 6, 6 minus 6, 0. Now, we understand if our permutation, for example, sigma, is for n, and it's okay, is a1, a2 to an, we want to find for an plus 3. For n plus 3, we consider what? 2, 3, 1, and we add by 3. So because they are 1 to n, they start from 4 to n plus 3. So a1 plus 3, a2 plus 3, to an plus 3. Now I want to prove that it is equal to 0. How? Here I say, okay, a1, the first one, let me write, the first one we multiply by 1, the next one -2, the next one 4, and this one -2 to the power of n minus 1. This one 1, -2, but here you multiply this one by what here? By 4. This one by what? -8. And this one, it is n plus 3, -2, n plus 3 minus 1, n plus 2. And this one will be -2 to the power of n plus 1. So now we know it is 0. a1 times 1, for example, minus 2a2 to -2 n minus 1, an is 0. Now we want to use this and prove also it is 0. So if we here a1, if we factor from 4, this part, let's focus on this part. So let's write from here. It will be 2, 3 minus 2 minus 6 plus 4 times a1 plus 3 minus 8 times a2 plus 3 and to -2 to the power of n plus 1, an plus 3 plus -2 to the power of n plus 2. Now, if I calculate that, because I want to find this term here, I say, okay, I calculate 3, I take 3 outside. 2 minus 6 is what? Negative 4. And I say, okay, it will be 4 times 3, 8 times 3. If I factor from 3, it will be 4 minus 8, 2 plus negative 2 to the power of n plus 1. Also, we have plus negative 2 to the power of n plus 2. And here, for a1, a2, if I factor from 4, it will be a1. The next one will be negative 2a2. And this one will be negative 2 to the power of n plus 1 minus 2, because I factor from 4, which is 2 squared, which is n minus 1 an. And now, I know from this part, if I call this one star, from star, I know it is 0. From star. So I should prove that the rest is also 0. So here I say it's negative 4 and okay, so if we factor here from 4, we will have 12, 1 minus 2, and again plus negative 2 to the power squared, 2 negative 2 to the power of what? We factor from 4, so it will be n plus 1 minus 2, which is n minus 1, plus negative 2 to the power of n plus 2. So here, there are some around 5 important identities. You should memorize them. If you had any question about the solutions, the ideas, feel free to send message to my WhatsApp number in the description and comments. And also subscribe my YouTube channel to get next videos. You can use also the cards to improve your problem solving. My playlist for USA, British, IMO International. Okay, so one important identity is this 1 plus r squared to Rn equals Rn plus 1 minus 1 r minus 1. Here r is what? Negative 2. So it is equal negative 4 plus 12. Negative 2, you say, okay, negative 2 minus 1, negative 2 minus 1. Negative 2 to the power of n, because it is n plus 1, n minus 1, n minus 1 plus 1 is n. Minus 1. And plus negative 2 to the power of n plus 2. Now here you say, okay, it's negative 3. Negative 3. If we cancel here, we have negative 4. And negative 4 times this will be plus 4. With this, they will be cancelled. This one and this one. So here, if I factor from negative 2 to the power of n, I have negative 4. And if I factor from negative 2 to the power of n, it will be negative 2 squared is left. So it is what? Is 4. 4 minus 4 is what? 0. So 0 times this is 0. So we've proved that if we prove for n, if n is okay, n plus 3 is also okay. So if for base cases, for n, 2 and 3, we said these are okay. So we've proved for n 3k and 3k plus 2. Also, we've rejected for n that is 3k plus 1. If you had any question about the problem of this, about the solution of this problem or other solutions, if you want to learn, cover the ideas that are useful in algebra, combinatorics, like here, one of the most strongest idea, I can say one of the strongest idea here, considering a small example in combinatorics. Also in geometry, there are around 50 important ideas. If you want to learn them, as I said before, feel free to send message to my WhatsApp number and comments. WhatsApp number in description and comments. Also subscribe my YouTube channel and turn on notification to have next videos.